Earth, the blue planet. It's been warm and hospitable for the last 11,000 years. But how much longer will that last? In the not too distant future, temperatures could plummet. In parts of the northern hemisphere, the temperature could drop to -23 degrees Celsius. For the first time in 200 years, ice may form on the River Thames. And by the time the temperature has fallen to 25 below, public transport will have failed. 3 meters of snow could fall, making roads impassable for all but snowmobiles. Anyone caught outside would freeze to death. Buildings would collapse under the weight of snow and ice. Infrastructure would crumble, and society would struggle to survive. Is this a vision of our future? These days, our peaceful climate bathes fertile lands in warm weather, allowing civilization to flourish. But it hasn't always been that way. The Earth follows a cycle of freezing ice ages, followed by warmer interglacial periods. Recent centuries have been kind to humans. The last 10,000 years have seen just one major cooling. But that could all change. Some scientists now believe that this predictable cyclical climate isn't so predictable after all. They suspect that the Earth is capable of suddenly plunging into micro-ice ages or giant freezes lasting up to 1,000 years, with devastating blizzards that could cripple our cities and destroy crops. And they believe this new freezing climate could hit us far sooner than we think, with little or no warning. The people of Montreal have already got a tiny taste of just how deadly a giant freeze can be. On the 5th of January 1998, a violent ice storm struck, coating the city in freezing rain. It turned the thriving metropolis into a frozen, barren wasteland. Journalist Alan Hustack lived through this icy disaster. Hustack returned home from work just as a power cut struck the city, something all too familiar to the residents of snowy Montreal.
The first evening was kind of like a carnival. You lit the fireplace and lit the candles and knew that tomorrow everything will get back to normal, and of course tomorrow it didn't.
This massive storm was far from normal, and it was getting worse. Over the next 5 days, it dumped 10 centimeters of freezing rain on Montreal. It fell as water, but froze on impact to build up layers of solid ice. The weight of this ice crumpled electricity pylons, and the city buckled. Up to 1.4 million homes had no power. The ice storm exposed the Achilles heel of modern cities, our total reliance on technology.
We are so used to, in a large North American city of 3.5 million, to having your television, having your microwave, having your computers, and it was gone in an instant. It was gone in an instant.
It was 5 icy days and freezing nights before power finally returned to Montreal. The damage totaled more than $2.5 billion, and 30 people died. The storm destroyed over 3,000 electricity pylons and all but one line or grid feeding the city. But Hustak believes the situation could have been a lot worse.
We were left with one grid, and had that grid gone down, I mean, the city would have had to have been evacuated because we would have been without electricity for 2 or 3 months.
This was a scary lesson for everyone living in a modern city, thinking themselves safe in the warmth of their homes. And the ice storm that made Montreal citizens burn their furniture just to stay alive lasted barely a week. Imagine what would happen in a giant freeze, one that lasted for years. Your own city could be covered in ice, not just for days, but for weeks, months, or even a lifetime. Is this an accurate vision of the future? Scientists are piecing together a clearer picture of how our climate has behaved over the last 160,000 years, and it's not a comforting image. To understand what might cause a big freeze in the future, we need to look at the past and discover what's driven our planet in and out of ice ages over millions and millions of years. Normally, our planet swings rhythmically between cold ice ages and warmer periods that scientists call interglacials. These swings are caused by the Earth's rotation around the Sun. Earth's orbit is far from simple. It varies in a number of complex ways, the most important being its shape. It's not always a perfect circle. Through a cycle lasting about 100,000 years, the orbit goes from almost round to being stretched into an oval shape, and then back to almost round again. In the more elliptical orbit, we travel about 5 million kilometers further away from the Sun. This means less sunlight reaches the Earth, and an ice age is born. This vast astronomical cycle causes large temperature swings that are slow and predictable. We live in a warm interglacial period, but eventually Earth's orbit will alter once again and a new ice age will freeze the planet. This shouldn't happen for another 10 to 20,000 years. But if you think you're safe from the cold, then think again. New research suggests that our climate is in fact far less predictable and far less stable than we previously thought. This new vision was revealed by geologist Richard Alley.
The climate sometimes jumps out and surprises us. Sometimes it tips over, sometimes it flips a switch, and it's not always nice and smooth and easy to predict.
Alley's passion is frozen H2O. He's one of the world's leading experts on ice. He studies the climate by collecting deep samples of ice called ice cores. Ice stores a treasure trove of data about the climate of centuries past. Every year, snow falls and forms a layer of ice on the surface of ice sheets and glaciers. And each of these layers remains on the surface until it's covered up by the following year's snowfall. Over thousands of years, these layers build up, one on top of the other. And the more layers there are, the older the block of ice. To access this ancient ice, scientists send a hollow drill deep into its frozen heart to pull out a solid column, an ice core. Drilling deeper and deeper into the ice exposes layers that first fell as snow thousands of years ago. The chemicals trapped within the layers have remained untouched ever since. Studying ice cores is a bit like having a time machine. By comparing the thickness of each layer, Alley can deduce what happened to the climate year by year. He made his most amazing discovery in Greenland when he drilled out a 3-kilometer deep ice core.
We took 2-mile-long ice cores and we got over 100,000 years of the history of the climate, and it was phenomenal.
The ice history uncovered by Ali reveals that the major climatic swings between warm interglacial periods and ice ages are only part of the story.
The climate usually sort of changes nicely and smoothly and gradually, and sometimes it just changes. And years, a single year, there's huge climate changes.
These huge and sudden swings destroy previously held beliefs that our climate is in any way predictable.
We stood there in a snow trench in Greenland and looked at this record coming out of the ice cores, and the world changed. And that was just phenomenal, just extraordinary discovery.
The evidence shows that our climate swings wildly between extremes, with changes happening not just within the ice ages, but also within the interglacial periods that scientists once thought were stable. The bad news is that these swings are big. They can last over 1,000 years. And even worse, they can act rapidly, striking and totally changing our climate within a decade.
The size of many of them was sort of half the distance between an ice age and today. In central Greenland, 18 degrees Fahrenheit, 20-some degrees Fahrenheit for the biggest ones. So these are big changes in something like 10 years.
Ali's research shows that the climate can change suddenly. The warm existence enjoyed by most of us could disappear should our weather turn hostile. But even more worryingly, this wildly swinging climate appears to be a normal state of affairs. It's actually the stable weather we've enjoyed for the past 10,000 years that's the freak of nature.
We've seen this history of boing, 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 boring. And that boing, boing, boing sort of looks like what's normal, that we should be used to crazy climates, and this boring that we have is sort of as good as it gets.
If Ali is right, another big freeze could be on the way. One that could cripple major cities, destroy crops, and change the socio-political face of the planet. But how and when might it strike? Scientists have traveled to some of the most extreme places on the planet to identify what it is that causes dramatic climate change. And a new theory suggests that it may be triggered not by cold, but by a combination of fire, brimstone, and extreme heat. If the Earth's current warm, stable climate is indeed an anomaly, then a new freeze could occur suddenly and with devastating results. Scientists have discovered that the Earth's true climate swings rapidly between warm spells and freezes. And they've identified one possible culprit: volcanoes. Ironically, this clue came from deep within ice. Lonnie Thompson is a glaciologist who specializes in plotting the history of our climate by studying ice cores.
Ice is like a time machine in that it records the history of the past, and the deeper you go, the further back in time you go. You can look at the 20th century, but you can look at thousands and thousands of years of history.
Thompson has collected cores from all over the world. His impressive collection is kept at -34 degrees in his cold room in Ohio.
These cores come from the South Pole in Antarctica. These are Boner Churchill from southeast of Alaska, Kilimanjaro from Africa, Dai 3 in southern Greenland, a Huascaran from the Andes of South America. These are cores that come from around the periphery of the Greenland ice sheet.
What makes the ice cores so useful to climatologists like Thompson is that they absorb and perfectly preserve chemicals and particles from the atmosphere. This allows scientists to record ancient atmospheric composition and discover what natural phenomena occurred at the time.
You can see when we put lead in gasoline. You can see when we passed legislation to take the lead out of the gasoline. So they're a very good recorder of anything that's in the atmosphere.
They can preserve sand and dust from years of drought.
The beauty of the ice is that this dust is preserved as it fell. It represents a drought that occurred in Africa 4,200 years ago.
They also preserve dark layers of volcanic ash. Dotted around Thompson's cores are the records of volcanic eruptions.
So if you look at these, you can see the eruption of Huayna Patina from February 17th, 1600 AD.
By measuring the concentration of atmospheric gases and the radioactive isotopes trapped within the layer of ice immediately after the layer of volcanic ash, Thompson is able to determine the climate of that year. And he's discovered that after major eruptions, the temperature drops. Somehow, the big eruptions trigger sudden coolings. Erupting volcanoes fire vast quantities of ash into the atmosphere. This ash is made up of such tiny particles of rock that it floats on the wind. Traveling around the globe, it forms a blanket high in the sky, blocking out sunlight and cooling the planet below. The ash then falls to Earth to be trapped in the ice. By dating each layer of ash in the core, Thompson is able to build up a picture of what happened to the climate after each eruption.
1815, the eruption of Tambora. Indonesia volcano led to the year without a summer.
In Europe, the summer temperatures were 3 degrees lower than normal. Wheat crops failed, and thousands of people died of famine. The United States was also affected.
Here in Ohio, we actually had snow in July during that summer. No crops were produced. So these volcanoes can have a very immediate impact on the climate.
But scientific analysis of the ice cores has revealed that volcanoes affect our planet's temperature in other ways too. Ash from eruptions isn't the only cause of a sudden freeze. Volcanoes also have another weapon. It's a gas. It can actually reflect the energy from our only heat source, the sun, back into space. Along with the ash cloud, volcanoes pump a cocktail of gases high into the atmosphere. Volcanologist Dave Schneider analyzes these gases by flying over the craters of active volcanoes. His laboratory is the state of Alaska, the most volcanically active area in the United States. Today, Schneider's flying to Mount Spur, an active volcano that's been smoldering over the last year. He'll fly directly over its crater and through its gas cloud. The horizon is littered with volcanoes, and Schneider knows them all.
There's a lot of beautiful volcanoes in Alaska, and one is more interesting than the next, and it's hard to come up with. It's like asking which of your kids do you like the best.
After an hour, they arrive at the simmering volcano.
And right now we're just flying over the caldera rim from an eruption, tens of thousands of years ago, formed a large caldera at the summit, and then the new summit here is a volcanic dome that has grown in that crater afterwards.
In his airborne laboratory, Schneider gets down to work.
What was our altitude right there, Ron?
82 right now. You want it a little bit lower?
Schneider analyzes the volcanic cloud for clues as to how it alters the weather. And it doesn't take long for him to identify the volcano's secret weapon, the gas sulfur dioxide.
There's a faint odor of sulfur dioxide that you can smell as we fly by, just pulling it in from the air vents. And that's exactly what we're trying to measure here.
When it comes to global cooling, sulfur dioxide is the most damaging of all a volcano's gases. Big eruptions blast sulfur dioxide high into the upper atmosphere, where it reacts with water vapor to form droplets of sulfuric acid.
Sulfuric acid droplets are very shiny, much like this mirror, and they reflect the incoming sunlight back up into space, which would have the net effect of cooling the Earth.
They act like billions of tiny mirrors floating above our planet, reflecting the sun's light back into space. The result is that far less sunlight reaches the Earth, and so temperatures drop. The effect of sulfur dioxide is so powerful that even non-explosive eruptions, producing little or no volcanic ash, can drastically affect climate. In 1783, Mount Laki in Iceland began to ooze sulfur-rich lava from cracks in the Earth's surface. It produced no ash, but lots of sulfur dioxide. This caused the average temperatures in the eastern United States to fall over 5 degrees the following year. But are the temperature hiccups triggered by volcanoes big enough to seriously affect life on Earth? Some scientists believe they are. In fact, a volcanic eruption that occurred almost 1,500 years ago changed the weather so radically that it may have altered the course of human history. Historian David Keyes thinks that a colossal eruption in 535 AD entombed our planet within a cloud of volcanic gas and dust.
A lot of the accounts from the period actually say that the sun shone like the moon for a year.
The drop in global temperatures had huge and surprising side effects around the world. Old empires were destroyed and new ones flourished. The world we live in today emerged out of this global chaos.
It was a catastrophe and hugely changed the demography and the society of large swathes of Africa, the Middle East and Europe, and as a direct result in that, changed history.
A climate change of just a few degrees could send the weather tumbling out of control in many parts of the world.
Massive storms, droughts, floods, that sort of thing. Really, it's these extreme weather events, which are the business end, if you like, of climatic problems.
Every year, our cities could be pummeled by countless hurricanes, floods, and tornadoes. And the triggering of such extreme weather events could also kickstart an unstoppable chain reaction, one that could lead to global catastrophe. It's a bit like a set of toppling dominoes. The first domino to fall would be climate change, which could cause more violent weather in parts of the globe. This weather chaos would cause crops to fail, which would lead to famine and starvation, and then disease. And once dominoes start tumbling, nothing can stop them. Next would come civil unrest, the collapse of a society's infrastructure, and eventually, total anarchy. But there's a twist in the climate change tale. Different countries could be affected in different ways, and some scientists believe that the most advanced societies could be hit the hardest, because the more developed the society, the more there is to be broken.
The higher you go, the further you can fall. So if you have a society that's very, very complex and very sophisticated, it's very, very vulnerable if things go wrong.
Less advanced cultures, although still affected, don't have so far to fall, and they could suddenly find themselves able to compete with previously dominant cultures on a more equal basis. The result could be a realignment of political and military power, the type of free-for-all that often leads to war.
It's a bit like a sort of grand game of geopolitical musical chairs, where suddenly you get climatic problems and their repercussions, and everybody has to swap round a bit.
History has shown that even small changes in the climate, sometimes of no more than a few degrees for a few years, can change the course of civilization and push societies to the brink of disaster. But what would happen if the change in the climate was long-term and much more severe? Could it have the power to wipe out a whole species? The answer may lie deep below ground in the Great Saltpeter Cave in Rockcastle County, Kentucky. Anthropologist Kenneth B. Tankersley studies sudden climate change by examining fossils. His research may shed some light on the power of the weather.
What we find here, I think, can help us adapt to future climatic change. Literally, our survival may be in the sediments within this cave.
Tankersley leads a team deep underground as they hunt for evidence of a sudden climate change that took place at the end of the Pleistocene period, 13,500 years ago.
Caves are environmental magnets. They collect plant and animal remains primarily because caves function as Mother Nature's sewers.
The constant temperature and humidity in the caves preserve animal bones in sediment layers, one on top of another, perfectly filed in chronological order.
We go deeper and deeper in the cave. We're going further and further back in time. I've often thought that if I walked just a little bit faster, I could actually catch up with the people and the animals that lived during the last ice age.
Tankersley's team works its way deep into the cave system. They're searching for fossils. Accumulations of fossil bones and plant material in caves are called middens, and they're a good indicator of how changeable our climate has been in the past. Tankersley uses a simple hand-powered coring tool. The deeper he drives it into the ground, the older the layer of fossils he extracts. He finds a bone bed, a layer littered with fossils of creatures that are now extinct.
The reason we have a bone bed is because the environment's going under rapid, profound, global climatic change. Let's see what we have in here.
Tankersley's layer of fossils dates to the end of the Pleistocene period, a time of dramatic climate change. It contains the remains of strange and ancient creatures, all of which have vanished from the face of the earth.
Looks like it was probably from the heather vole, the giant snapping turtle, a piece of pygmy shrew, a phalange, or toe bone, if you will, of Platygonus compressus.
Platygonus compressus was a kind of giant pig. It was one of a group of creatures hardest hit by sudden climate change, the mega-mammals.
Mega-mammals are literally giant beasts that lived during the last ice age. Imagine for a moment a beaver that was the size of a black bear, or a ground sloth that was the size of a tree.
Tankersley believes that many of the mega-mammals died at the end of the Pleistocene period as the climate changed. It's uncertain why they disappeared, but Tankersley thinks sudden climate change played a role in wiping them off the face of the planet.
More than 30 different types of mega-mammals disappeared in a very short period of time.
The mega-mammals had very slow reproductive rates. It could be that the lengthy periods between generations meant they were slower to adapt to change.
The climate changed rapidly and profoundly and globally, so fast that the mega-mammals did not have a chance.
Tankersley's research shows that sudden climate change can affect the survival of a species. So what would it mean to us if the weather suddenly changed? A drop of a few degrees can cause crops like corn, rice, and wheat to fail, leading to global famine. And Tankersley fears that humanity may stand little chance of survival if a massive freeze should strike.
Now, if we were to have another ice age, what we need for our own survival, if we were to land, would be tied up in glacial ice. The amount of areas that would be inhabitable, the amount of areas where we could produce food would be greatly reduced.
Could we be living on borrowed time? Could humans too be wiped off the face of the planet? Understanding what triggers climate swings may be our only chance of survival. But so far, the news isn't good. It appears that we could be the ones to set off the next major freeze. The current interglacial period has allowed civilizations on Earth to flourish. But if, as scientists believe, this is the exception rather than the rule, we could be facing a sudden cooling of global temperatures. And it could strike sooner than we think. And we still don't know what triggers rapid and sustained climate change. Volcanoes can cause short-term cooling, but what about giant freezes?
If volcanoes could get organized, they could rule the world. But they don't seem capable of triggering ice ages. There's no way for an Alaskan volcano to tell an Indonesian volcano that it's time to erupt.
The cause of giant freezes may lie deep within our oceans. Temperature plays an important role in the movement of ocean currents. Warm water is less dense than cold water, so it tends to rise. Conversely, cold water tends to sink. The seas at the equator receive more sunlight than those at the poles, so water there warms up and rises and moves towards the colder polar water. This movement is called the Great Ocean Conveyor. Once the warm water arrives at the poles, it cools and then sinks, and is forced back to the equator along the ocean floor. The movement of warm water carries with it warm air. In the North Atlantic, that air movement is called the Gulf Stream. It carries the heat equivalent of the output of 1 million power stations. This is the main reason why England stays relatively warm, while at the same latitude, Canada has ice fields. The movement of warm water and air not only spreads warmth around the world, it also helps to stabilize weather patterns. This stability has helped civilization to flourish and has seen our population soar from a mere 4 million to over 6 billion people today. But the ocean currents haven't always flowed so reliably. If the function of the conveyor is to keep the climate stable, how could it set off a freeze? The theory says that if the conveyor ever stopped, the distribution of warm water and warm air would also stop. And that could lead to climate change. But what on earth would be powerful enough to stop the conveyor? One clue may come from the last big freeze to hit the planet. As our planet exited the last ice age around 13,000 years ago, temperatures started to rise. This caused the North American ice sheet to melt, and a vast lake of fresh water became trapped where Hudson Bay lies today. This lake was dammed by mountains of ice. But in one dramatic event, these dams burst, and 9,500 billion liters of fresh water poured into the North Atlantic, about 450 times the volume that passes over Niagara Falls every day. This immense influx of fresh water drastically decreased the salinity of the North Atlantic, which wouldn't have mattered much, but for one thing. Fresh water is less dense than salt water, and it refused to sink. These density changes meant that the great ocean conveyor started to slow down, and warm air stopped circulating. Weather patterns were affected, and temperatures dropped. Richard Alley's ice core records show dramatic swings in climate all over the world.
It affected probably the northern hemisphere almost instantly, and the southern hemisphere within 100 years or so.
The freeze is known as the Younger Dryas, and ice core records show that it chilled our planet for more than 1,000 years. This was the last big freeze to strike the Earth. It happened over 10,000 years ago, but it could be about to happen again. Something is affecting the natural balance of our planet, something that could bring our stable weather to an abrupt end sooner than we or scientists thought. Global warming. This doesn't mean longer summers and more pleasant winters. Far from it. Global warming is actually throwing our fragile weather into disarray, and nobody really knows what the consequences will be.
The Earth's climate is a little bit like a drunken human being. If you leave it alone, it just sits there. And when you force it to move, rather than going smoothly, it staggers on its way.
It's not known if our planet will continue to enjoy the stable, pleasant weather it's had for the last 10,000 years. But some scientists worry that rising global temperatures might be upsetting our delicate climate system more than we realize. They suspect that global warming might actually push us staggering into a new freeze. As temperatures rise, the melting Arctic ice in glaciers and ice sheets will pour cold, fresh water into the oceans. This could slow down the ocean conveyor and cause a drop in temperature in parts of the globe.
There's this slight worry that we are warming the world and that this will cause melting in Greenland. And if too much fresh water gets into the North Atlantic, global warming could cause freezing around the North Atlantic, so that some people would actually see a rather startling cooling from global warming.
Scientists are currently carrying out studies to learn just how big an impact global warming might have on global freezing. Many, like climatologist Don Perovich, have traveled to Barrow, Alaska, the most northerly settlement in the US, to study global warming.
If there is global warming, this will be where you'll see it first. This will be where the signal's the largest. So naturally, that's where you want to look.
Perovich studies the impact of global warming on ice cover, and his findings are disturbing.
Roughly speaking, the Arctic sea ice covers around the size of the United States. And if you look back over the past 30 years, each decade it's lost an equivalent size of New Hampshire and Colorado.
Some scientists believe that within 5 decades, Arctic sea ice in summer may disappear completely. This devastating warming is thought to be caused by emissions of greenhouse gases into the atmosphere from burning fossil fuels. To help understand the effects of this warming, Perovich travels out onto the Arctic sea ice. He drills a hole through the ice to measure its thickness. And Perovich's studies reveal that the Arctic ice is not just shrinking, it's also thinning.
We see the areas changing a few percent per decade, and you might say, well, so what? Well, there's another dimension to the ice cover, and that's its thickness. And we really want to know how that's changing.
In the 1960s, the Arctic sea ice was more than 3 meters thick on average. Today, it's less than 2.
And that's a 40% decrease in the overall average thickness. Perennial ice cover could be gone in 50 years. What that means is that in the summer there'd be no Arctic sea ice. And that's something that hasn't occurred in hundreds, if not thousands of years.
The loss of Arctic sea ice could lead to disaster. The ice currently acts as a plug, stopping glaciers of freshwater ice from simply pouring into oceans. But should the sea ice disappear, these freshwater glaciers would surge into the oceans unchecked. This would decrease the salinity of the oceans and disrupt the smooth running of the great ocean conveyor. As more and more ice melts, just as it did around 13,000 years ago, it could threaten to trigger another big freeze. At present, nobody knows if or when this will happen, or how severe it could be. But if it's even a fraction as severe as the younger Dryas freeze, it could threaten life as we know it. The Earth may be facing a sudden cooling. Around 13,000 years ago, at the end of the last ice age, the planet rapidly warmed. It's believed that the ocean conveyor shut down, triggering a sudden freeze. Today, global warming is melting glaciers and ice sheets, and thereby freshening our oceans. And scientists are worried that this climate change could trigger another giant freeze. Oceanographer Neil Bogue has come to the Greenland coast to study the North Atlantic. He believes that right now, global warming may be shutting down the ocean conveyor and endangering our planet.
I think there's evidence to indicate that it's slowing down. Whether it will continue or whether there will be a reversal, these are the things that our research hopes to answer.
Bogue and his team measured the salinity and temperature of the Labrador Sea, a crucial part of the icy North Atlantic. These measurements tell him how much icy cold water is sinking and how quickly. They give an excellent indication as to the great ocean conveyor's state of health.
The research we're doing here in the Labrador Sea is crucial to making much better predictions about the effects of changes in the ocean conveyor belt on climate.
They're here to launch a sea glider. This high-tech torpedo measures the salinity and temperature of the Labrador Sea. Bogue hopes that this new technology will allow them to determine whether or not the great ocean conveyor is shutting down. The scientists are at the mercy of the weather, so sometimes they have to work at night. They must launch the sea glider in deep water, which means operating 65 kilometers from the coast. They launch the glider and watch it disappear into the pitch-black North Atlantic. Their work reveals something about this part of the conveyor that we didn't want to hear.
Deep water is not being formed as fast. So the thing that drives the ocean conveyor belt, the driving force, is actually not present as strongly as it has been in the past.
Bogue's concerned that changes in the great ocean conveyor could take place in a relatively short period of time.
Significant changes could take place in timescales of decades, tens of years, 10, 20, 30 years, certainly within a scale of a normal human lifetime.
And he's not the only one concerned. Researchers from the National Oceanographic Center in Southampton have been studying water flow in the Atlantic over the last 50 years. Their studies show that until 2004, the ocean conveyor stayed constant, but then it suddenly changed and slowed down. They too believe that ice melting because of global warming could shut down the ocean conveyor. Their frightening prediction is that in the next 20 years, the climate in Britain and continental Europe will become more like parts of Canada. Temperatures could drop up to 6 degrees. If they're right, this could mean catastrophe. Crops will fail, people will starve, and that will be just the beginning. As temperatures plunge below zero, cities like London will be thrown into chaos. There will be power failures, and drinking water supplies will freeze. Soon, public transport will cease to function. Cars won't start, and roads will become covered with snow and ice. Only people with snowmobiles will be able to get around. Because the human body can't survive in temperatures below -35 without specialist survival clothes, anyone caught outside will freeze to death. Roads and rivers will become impassable. The city will become slowly entombed in snow and ice, and buildings will start to crumble and collapse under the weight. Eventually, the city will die, and society will be pushed to the edge of oblivion. It's not an optimistic vision of the future. So how likely is it that such a freeze will strike? We may experience a short-term cooling brought about by volcanic eruptions, which could trigger wars and famine. But we could be facing something much bigger. Some scientists now believe there's a 50% chance that the Great Ocean Conveyor will shut down within the next 100 years. This could bring about radical changes in global weather patterns, including violent storms and floods. There'll also be dramatic cooling in parts of North America, Britain, and Europe.
The folks right around the North Atlantic, it would be really cold in the winter, and you would probably see the British buying a lot of snowplows.
It's likely that our climate will be far more violent than the peaceful one we enjoy today. It'll no longer be stable, and could catapult the planet into a big freeze. A freeze that would change the world as we know it, forever. Floods and tornadoes. And the triggering of such extreme weather events could also kickstart an